Hello, welcome to another Red9 demo. This one I want to go through our Health API, the HealthManager UIs. And before we do, I'll give you a bit of a background. Basically, this is designed to validate files, to validate rigs, to validate pretty much anything you can physically think of within a scene. We use it extensively. Basically, any files, any rigs we send out, any facial rigs have to go through the validation process. And we've got a huge list of tests that we run. And it's a way of comparing, doing deep analysis on files before you send them out to make sure that they are in the state that they should be. And the tests tend to grow. What we tend to do is we'll send a file out. If something comes back as an issue, we'll write a quick test and we'll add it into the rig testing compound itself. And then we know that that issue has gone away forever because it will always get checked as we do the tests. Now, by default, if we open the thing up, it's here, HealthManager. By default, you don't get a huge amount with it in terms of the actual compounds. These are compounds, these ones here, and you'll see as we click on them, it shows the tests that are set to run within these. And there's a very good reason for that, because we can't tell how you want to test, what you want to test within a rig. It's really down to TDs. This is a tool for TDs to set up and then pass on, if you like, to animators, etc., to say, you know, this test has to pass. By default, you get these four at the top. These ones here are within our testing suite, and these are internal tests. And what I'm going to do first of all is just show you the extent of this. So this is the base rig validation. This is the one that our Puppet rig has to pass before we send any builds over to clients. And you can see these are all the things that have to run, and they have to run in this order. So there's a sequence about this thing. And if we click on any of these, it'll go through and give you an idea of what it's actually looking for, what the default args are, and some class specific stuff that's in there. So I'm going to run this on this file. Now, this is obviously an animation file. It's been referenced in, so we have namespaces. I think we also have audio. Yeah, we do. We also have audio in the file. So there's no way I could send this out to a client as a rig. If I select this thing here and I go run health, instantly before I do, you'll notice there's two notations here. One's called collection, one's called compound. A collection is a set of tests that have no correlation to each other. It's just tests that can run in any order, and they don't all have to pass for it to be complete. Whereas a compound is everything in this has to pass, else this test will fail, this validation will fail. So if I run health, it'll go through our rig and it'll give me a status check of everything that's in that file. So I haven't actually done any fixing here, I've just gone through, and you can see we've got all sorts of fails in here. If I sort by status, all these are passed, so I'm not bothered about these. The amber ones are warnings. They're tests that are set not necessarily to fail, it's just a warning if something goes wrong, as a hint. But you can see we have no targets present, and this is set to find all nodes of type audio, and if there are any, it's a fail because I don't want audio in the rig sent out. There are namespaces in the rig. Character set is named incorrectly, it's expecting character. Each test generally has inside this, it will tell you what it's looking for. Skeleton tolerance, this is a really cool one. This is basically, it goes through from a given root node and it'll tell me all of the tolerances with all of the joints inside that skeleton. And again, we use this to validate that skeletons are at 0 before we send them out. And again, this obviously isn't because there's an animation file on it. The rig has keys, we have turtle nodes. If I run the fix methods now, it'll go through, it'll try and fix what it can. There's only one that failed there, it's still the tolerance, and that's basically because within the skeleton tolerance itself, it will never get back to 0 because it's an IK rig. If we set everything to FK, that would return back to 0. So that's a quick overview. That's basically me going through this rig, checking everything that I can think of that we need to validate before we send this asset out to clients. And that's the concept. But let's get into actually doing this and actually writing this ourselves. As I say, these are things that you write. We've given the API, we've given you this all available test, which is effectively everything that we've got. And again, we'll run through this in a minute with the test asset. So these are all the available tests that are in the API. If you open up our API docs, let's just open them back up from the root, and we come down to the optimizer. This is the overview of the optimizer and the health systems. They're all within the one module. Health validation, health tests, and then if you come down, further down, you'll see all of the tests. Here we go, everything that we've currently got within there that's exposed. Some of these are pretty extensive tests, and like I say, we'll go through those in a second. Okay, so let's do a proper example. Let's actually go to a proper production file. So this is a file that I know has multiple issues. but they're all the kind of issues that are actually quite difficult to spot. So first off, it said health scene test failed. This is a side product of the health suites. This is basically saying we are going to test everything within this file once you open a file against the mayor scene units, mayor axis, and the time units as an initial test for animators. It might be that, for example, the animators left the file at 24 frames a second, saved it, everybody else is opening it, you're exporting it, everything's coming in wrong, and it's the kind of thing that's difficult to test. That's all set. And that comes out of our project management systems. This will go through at a later date, but all of the data comes from this project management, and that's per project. So again, we'll go through that in a different test. I just wanted to validate that. Okay, so this is a face rig. This is one of the Red9 face rigs. We've got some animation data on it. I want to test that this is fit for purpose. So again, let's open up the HealthManager. We'll come into the compound, we'll go all available tests. I know I need to test blend shapes because I want to make sure that we've got all the blend targets in there. I want to make sure the blend shape itself is valid. I want to make sure that we've got all the things named correctly, and we'll just go through some of the tests. So let's say, for example, let's do one of the worst ones. For example, let's go missing indexes test. Instantly that turns red. And if we open this thing up so you can see why it's turned red, what we'll do is select on it, you'll see it says this sculpt blend index 12 is missing. And what that means is that if I select our blend and I go into our blend shape, somewhere down here at 12, somewhere like, so I think it's around there, at some point somebody's made a blend shape and then deleted that blend shape, or rather that blend target, and then they've carried on adding, which means that in this index, in the actual blend shape index itself, we've got a missing slot. Now, generally in Mayor it doesn't care. When you output to FBX, it's a big deal, because what it means is that the FBX itself, when it loads the data back, will catenate that index out so that slot 13 becomes slot 12, slot etc, etc. But when it loads animation data, it doesn't do that, and then it links everything to the wrong indexes in the blend shape, and it's a real pain. We actually wrote this for a client that was having this issue with their face rigs going out to Unity, Unreal. So the test finds it, the fix fixes it, and the fix is it's a bit of a hardcore fix. What it does is it finds the empty slot, and rather than building everything back, what it does is it inserts an empty padded shape in there with no deltas. It's a kind of thing that really the asset should be sent back and rebuilt, but if you're in production, you already have this. This will get over it because it now means that the FBX will load the data correctly. Okay. We also have, for example, let's do blend shapes exists. Where are we? Blend shape target test. So if we look in here, we don't have any of the blend shapes in this file. And again, if we open the results up, you'll see missing. Basically, it's missing all of the target original shapes. Now, most of the time that's not an issue, but it might be the case that you need these for your output, or you need them for your exporter. So again, we can fix it. That will go away and it will regenerate it. Now that's doing some pretty hardcore stuff underneath the hood. That actually will look at the nodes. It will try and unconnect anything that's currently connected to the blend nodes. It will turn off all the deformers that are before the stack in that to make sure we can get back to a valid state. It will regenerate all the targets, hook them up so they're all back to being live targets to that blend shape as you would have originally created them, and then it will connect everything back up. So again, it's quite a hardcore test. Blend shape node test. So this is going to check whether the names of the targets are actually as they should be. And we've got some other blend shapes in here that are named inconsistently. But to give you an example, if I take that and I call it something stupid like that, what the test will do, you can see that will come back into the test now. Sculpt blend, there we go. I've just called it whatever I called it, something stupid. What it assumes, or what it tries to do, is it tries to make sure that all of the targets are named as per the blend shape the blend shape alias and the blend shape node. So it makes sure that the targets and the geo that's sat in the scene actually named correctly, and if I fix it again, it'll rename them. Now those are just 3 tests that we've just fixed this asset with. Now these are the kind of things that are very difficult to spot. They're the kind of things that get into production and you spend weeks tracking issues down like this. And the idea with this is that you would go through, figure out the tests you want, maybe write your own tests, put them in a compound, call it validate outsourced compound or whatever you want to validate it as, run the test. If it goes wrong, you send it back to the person that sent you in the first place, say this failed the test and it fell for this reason. Okay. So let's go through actually writing these things. There are a few things within this that we need to go through. First off, what you see here is obviously what is coming from this compound, and the compounds are really easy things to test. If I load up this testing module, this is our initial testing module. This is kind of a blank module that we send out if you're a new client, and generally new clients we will build your own compound. So normally when I look into Red9 client, I've got a separate project for each client. Also turn those off because we don't want you seeing some of those, because some of those are private. And this is as simple as it gets. So this is the scene open test that you saw, the big pink warning that said the frame rate's wrong or whatever else it was wrong. And it's literally 4 lines of code. The key is that what you have to do is it has to inherit from the health validation class, and it has to have tests. And the tests, each test is set in a very specific way. And like I say, we'll go through that in a second. But first of all, let's actually look at some of these tests. So we've got the import statement here. Online Pro is a compile thing. You have to import through the Online Pro importer, which is there. Again, if you look into the documents at the top, it'll always say per module how to import the thing and what namespace to import it into. Okay, so let's look at creating some of these and how we go about it. What I'm going to do is we've gone through the import. That's the import statement, and what I'm going to do is I'm going to start looking at actually running some of the tests that we've just done. In fact, I'll reload the asset just to make sure we've got the file that has all the badness in it. Here we go. Ignore that, and let's run some blend shape tests. So blend shapes have targets. We were talking about the indexes. Let's have the missing index. Every test, by the way, has a test and a fix, and again I'll show you those in a second. And to run it, it's simple. You know, each test is literally just a function. The key is the function has to return a certain object, and like I say, we'll do that in a second. You can see that test failed, results failed, and if I want to fix it, I can just go test.run fix method, and that will go away, and it will test it, and it'll fix it. There we go. Added number 12, and if I retest that, that test should now pass. So they're all quite simple tests. There are some more complex tests within this. We've got quite a few that compare things like meshes. So for example, let's say because this is a facial delivery, I might actually want to check that this mesh is the same as a previous mesh. It might be that the client's delivered as a new mesh. We want to check all the vert positions. We might want to check the skeleton. We might want to make sure that all the joints are exactly where they were last time and that they haven't moved them around, because obviously that has a knock-on effect further down the line. So there are tests for all of those as well. I'm going to construct a simple test. In fact, what we'll do is we'll make a new compound. We'll actually make this new testing compound for ourselves. So let's do it actually in here, and we'll call it class. We'll call it I don't know, demo health test. Call it capitals. Now that has to inherit every test, and you'll see from this, every test has to inherit from the Online Pro validation. That's crucial. In fact, what we'll do is we'll just copy that whole set out, which is generally all I do. I generally just copy and paste this stuff. Okay, we know the tests are bogus. We want to set our own tests up, but this is crucial. So what happens is that when we open the UI up, it checks for anything that's inherited from this class. The key is the module that you're doing has to be loaded in memory, and then it'll inspect it and it'll find it and it'll put it in the available tests in the UI. And if I want to add some new tests, I'm going to add the blend shape test. So we know we had the R9 POPT, and we had one called blends. Oops, helps with no caps, and it helps make it spell blends. In fact, let me just copy the name of that test out. Blends missing. Now, this is a list of tuples. Okay, so the first thing is the test itself. The second thing are the arguments passed to it. I'm writing none, but you'll see in some of these, this is the rig test above it. You'll see in some of these we've got a dictionary, and that's basically the keywords that are then passed into the function once they're run. And you'll see some of these as well refer back to the project data. Again, remember me saying about the project object, this is taking the data directly from that. So in other words, if we switch the project, the tests migrate and they change as well. And again, this is all stuff that we'll go through maybe in a different demo. So we've got the first one. We'll add another one, which was the one where we want to go R9 POPT. Gosh, my typing is terrible today. R9 POPT, and it was. We have blend shape geotest. In fact, let's just copy those three out because I've already got these out. It saves me typing them. Okay, so we've got the blends have geo test, and we've got the blend shape name tests. Okay, so those are our new ones, and we'll just put those in for the time being. Incidentally, the doc string that you get for this, the doc string, I missed on a bracket there. The doc string is extracted, and that's pushed into the UI as well. So we'll just prove that. We'll just go, this is a new class test for facial data. That'll do. Okay. And we'll just save that out. If I come back into here, if I open the HealthManager back up, that test isn't going to be available because it's not currently in memory. So all I'm going to do is I'm just going to go away and reload that and reload the UI, which comes over here, which should be, where did we, there we go, there's our new test. So this is the one that we've currently just set up. And as I say, this will show up in here. If it's in memory already, you've actually sourced or you've imported the module itself, and then you work the UI because it does an inspect. And that's the info, class info that we've just put in there. Okay, so we've got 3 tests already. So let's write a test. We know as well within this scene, well, I know within this scene, we've got an issue. We've got the skeleton parent, should be called skeleton, not skeleton, because somebody's typed it in wrong, for example. So let's go away and write a test, and we'll add that in. Tests are really, really, really easy. If we start one off, because what we'll do is we'll add it in. We'll go def, we'll call it skeleton, excuse my typing, skeleton parent test. And this always has expected as an argument. It's just part of the initial setup for the thing, and then you can pass any other keywords that you want to this thing. We'll give it a doc string. Again, the doc string is extracted, and that's what you see in the UI. So this will test the parent node name above the skeleton root. Okay, put that in there. One of those, and we'll actually start constructing the test. Now, if you look at the examples in here, you'll see we've got a simple test and we've got a more custom test. We're going to do one like this, which basically is going to, most of this is kind of bumfluff really. This is stuff that's needed. This is the return. The actual test itself is just those few lines of code. But the fact that you've wrapped it and you've put it in one of these compounds means that whatever it is that failed will never fail again, because you run that on the asset, it fixes it, job done. So let's do one of these, and then we'll put it in the system. So we'll open that back up. Wrong one, excuse me. We want it in this one, don't we? So first thing is that we need health object. It has to return a health object. That's the key. This test, which is just a function, has to return an online popt health test object. And a health test object is a simple little class that just holds the results of the test that's run, and then it's passed to the fixed methods, and it's also passed to the validation class, and that's what it inspects to get the status of each test. Okay. I'm basically going to copy through some of this. We're going to hijack this test. Like I say, this is the one that's also in the doc, so it's easy enough to do. We'll just get rid of that. Call it skeleton parent test. Okay, we've got results expected. We don't really need that because we're not going to use it. Actually, no, we do use it because we'll call it skeleton. So we're expecting the name skeleton to be the parent test. Okay. We don't need any of that. What we're going to do is we'll get rid of this stuff. We'll set our pass. Okay. So we'll go if cmds.obj exists. I'm going to do it off the root name. I'm not going to do anything clever. We'll just go if the object called chest, which is our skeleton, exists. Let's get the parent of it. cmds.list relatives. In fact, we'll do again. This is only just an example, so I'm just going to quickly bang it through. If the parent exists, if we don't have a parent. So if not parent, we need to raise a fail. We haven't got a parent, we were expecting one. So we'll set the health object, and we'll do set failed. Set, why is that not doing that? Health object dot set failed. Thank you. No, it's just my typing is terrible today. Set failed. Okay, so if we haven't got a parent, we're going to fail it. Okay. If we have got a parent, so elif parent 0 equals expected. So if the parent that was returned is the same name as expected, then we pass. We know that's a good test. So we'll do health object, and what we'll do is we'll set the results. So this is a good one, because basically this is data that's then returned to the tests so you can inspect it. So results returned equals parent 0. Parent 0, okay. There are a few of these. We have results expected, results failed, and results passed. And these are basically just holders for the data. That's all, literally all they are. You can use them as you need. But again, I usually set those same ones. So we'll set that passed as well, because we know that's passed. So the first one failed, we didn't have a parent. Second one failed, second one passed because it was named as it was meant to be, which means the third one is going to fail because it's not named correctly. So again, we'll do set health object dot results. Where are we? Results. Again, results failed nodes. We'll add it to the failed nodes list. The tests by default are fail anyway, so if you don't set anything, this is a failed test, unless you set it passed. This stuff by default, if there are no results failed, then it's normally passed. We don't kind of need that, because again, we've already set this data up. We know these three cases. It's either set failed, set passed, or it's left, in which case it's a fail anyway. Okay, and then we return the health object. We have to return that health object. Okay, so let's just save that out. Let's do a quick test, just make sure I've not typed that wrong. So I'll just resource that. TH, which is what I've called it for some reason. What did I call it? It wasn't demo health test, it was skeleton parent test. Skeleton parent test. There's a test. If we just run that, it failed, and it failed because we know that's wrong. So we'll go test equals. Let's just catch that. Test equals, and if we go test dot, this is where you get the idea of why we're returning these. So the return expected is the fact that we're expecting skeleton and we didn't get it. The results failed will be the node that failed, which is that. So you get the idea of how we're running this. We can get the status of this thing back as to whether it's passed or failed, etc. But let's write the fix method quickly. So we're going to write a fix method. So we'll call it the same thing. Generally speaking, the test is called test, the fix is called fix. The names are the same between the two of them. This fix has to take the health object because we're expecting a health object. Again, that's the Python object that we're passing around to deal with. And the test is really, the actual fix is really easy. So we'll go if, a little bit of header code, if has run, because obviously we want to make sure that our test has run and we're not actually trying to compare it against an empty test. We'll just do assumed yes, we'll do a rename, and we'll call it, what are we doing? We're doing health, so we'll do health object dot results underscore failed, because we caught it and we put it in that node, so we know that's the wrong node, sorry, the object that was wrong. And we'll go health object dot results expected, and that's it. And then all we have to do is we have to inform the test what the fix is going to be. So at the top of this we'll go health object dot fix method. We bind it as the fix method. There we go. So this test now has a fix method, and that will get run when we run fix. So if I, again, we'll just resource that. There we go. There we go. And if we now do that from fix method, that node should magically, now, so it's renamed it. Now it's a really simple test. It's the kind of thing where you go, well, what's the point of that? Imagine you're getting a file, you have no idea what state it's in. It's a little pot of gold. It's one of these that, as a TD, you test the file, it does it, it fixes stuff, it never comes back to haunt you, as opposed to it gets into production, a week down the line someone says, that's named wrong, you go, shit, I've just exported 300 files, it's all, you know, etc, etc. You get where I'm coming from. Anyone that's been in production will get that instantly. So let's put all this together. Let's actually add that to the health test. In fact, before we do that, let's just open the HealthManager back up. I want to just show you one more thing in the old tests. We called it skeleton, what was it called? Skeleton, I can't remember what I've called it. Skeleton parent test, we called it. There we go, which is at the top there. Now then, This has shown up in the all available test now because it's a new test, and it's shown up because the module it's in has got a health validation object. And by that, what I mean is that this health object, sorry, this health module has classes that inherit from this validation. That kind of points the code to saying if it's got a validation test, anything in there called _test at the end must be a test or is available as a test. It's kind of a wide sweeping statement, but it generally works. So what I'm going to do is I'm going to add that test into this, and we'll say, actually, we will pass something in. We'll pass in what we're expecting, because you might want to change it. Let's just put that around. Oh, come on, Mark. I haven't had a coffee this morning. Expected, and we'll give it skeleton. In fact, we'll give it skeleton. There we go. Okay. Which basically means I'm actually passing that as a function. Sorry, I'm passing those as keywords into that test. So we'll just again we'll resave that. Come to Mayor, we'll reopen or re-import the class, or sorry, the module. Back to health. There we go. Okay, so it's in there. I'll just reinstantiated it again. So this is the one that we've just put in. We've just added that new skeleton test, and again, you can see in that if I run it, it will tell me failed. If I look in the data that's come back, it'll tell me results expected, results failed nodes is that one. There is also, if you want more information on this, if I put in, there's a log print, so let's put it into the bottom one because that's the one that we really care about. Health object, it's called log message. And log message is there as a way of doing nice pretty prints to things. It's just a formatted string. And if you look at this, we've got one here, plus it is literally just a string function. That's all it is. It's just a string that gets passed to the prints. So we'll put that in there. Fail node. We'll just what the hell? We'll just call it that, just so you can see that we've got fail node. That'll do. Okay, put that in. Back to this, and again, if we come back to the health test, I've just got to again re-import that thing. Re-imported that for some reason, don't know why. Health test, and we rerun that test there. There we go, and that's the fail that we've just put in. So again, it's changing the log prints. And if I do a fix, there we go, that's the fix. If I run that on all of it, you can see the state of the object. We know the missing indexes were already fixed. We still don't have any blend shapes in there, which means that the names of the blend shapes has failed because there aren't any. Skeleton parent has passed, but okay, we'll put that in. Let's do that, and we run the health test. Those are the fails. Run the fix methods. They've all fixed. It's added all the geo back into it. It's renamed the skeleton, and it's given you a status back of what actually has gone on in that test. This stuff, there is also a write function. So if you needed to write the state of this test out, that can be done as well. It literally is just .write. In fact, again, if you look at the top of the header here, I think we've already got one. There we go, write status, give it a file path. So just to summarize, it's a way of building powerful tests, usually collections of little simple tests that go away and in one general swoop they test everything to do with that particular file. It might be an animation file ready for export and you want to validate it before it hits the exporter. It might be that it's an asset from an outsourcer and you want to make sure that before you accept it and sign it off that it passes all the tests. The tests that we give you by default, there are some, like I say, there's some really powerful ones. We have skeleton tests, we have mesh tests, we have simple ones like display layers. Maybe we don't want display layers. There's all sorts. There are also a huge amount for the Emrig systems that we have in place to validate the more complicated aspects of our rig. But that's really for those people running MetaRig. But it's more the API, and it's more what it represents that we wanted to get through. Okay, if you have any questions, let me know. If you're a client and you don't have the test systems and you want to get involved, let me know, and again I'll send you that tester module out. The test is there by default. It's just these additional things. Like I say, the main caveat is that the actual functions, the tests have to be in a module, and that module itself has to have something that inherits from the validation for everything to pick it up and to be run, as we've just shown. Okay, hope that's all interesting. Thanks very much. Bye.